350 years, that is how long a single storm on another planet has been raging without stopping. 350 years ago, Isaac Newton was still alive. America did not exist. The steam engine had not been invented. And on a gas giant 500 million miles from Earth, a storm larger than our entire planet was already spinning. It is still spinning today. For centuries, scientists assumed they understood it. A weather pattern, a surface disturbance, something shallow and explainable. Then NASA sent a spacecraft directly over it. What they found shattered 3 centuries of assumptions in a single flyby. The roots of this storm go down 300 kilometers, possibly 500, 50 times deeper than the deepest point in Earth's oceans. And that is just where it starts getting terrifying. Before the discoveries, you need to feel what we are dealing with. In the late 1800s, telescope records measured the Great Red Spot at 25,500 kilometers wide, large enough to fit 3 Earths side by side. 3. When NASA's Voyager 1 flew past Jupiter in March 1979, the storm still measured 23,000 kilometers. Images Voyager sent back showed individual cloud features spinning counterclockwise at 430 kilometers per hour, nearly 4 times the wind speed of a Category 5 hurricane on Earth. A Category 5 hurricane on Earth lasts weeks before friction from land and cooling ocean water kills it. Jupiter has no land, no ocean surface, no friction anywhere in its atmosphere. Just gas extending downward for thousands of kilometers, growing hotter and denser with depth. In that frictionless world, a storm can run for centuries because nothing ever stops it. And the deeper it goes, the more dangerous it becomes. July 10th, 2017. NASA's Juno spacecraft makes its first direct pass over the Great Red Spot. 9,000 kilometers above the cloud tops, more than 200,000 kilometers per hour. Data window narrow. The key instrument is the microwave radiometer. Unlike cameras that photograph cloud surfaces, it detects microwave radiation emitted from deep within the atmosphere. 6 frequency channels probe progressively deeper layers, like a geological drill made of light. Scott Bolton, Juno's principal investigator from the Southwest Research Institute, announced the results at the American Geophysical Union meeting in New Orleans. The Great Red Spot's roots penetrate approximately 300 kilometers into Jupiter's atmosphere, possibly 500 based on gravity measurements in 2019. For context, Earth's deepest ocean point, the Challenger Deep, sits 10.9 kilometers below the surface. The Great Red Spot is at minimum 300 kilometers deep, more than 50 times deeper. Not a surface weather feature, a column of organized atmospheric violence, plunging deeper into Jupiter than anything in Earth's atmosphere comes close to matching. Andy Ingersoll, professor of planetary science at Caltech and Juno co-investigator, said it plainly. The roots go 50 to 100 times deeper than Earth's oceans, and are warmer at the base than at the top. Warmer at the base. Heat rising from deep inside Jupiter is feeding the storm from below. The planet itself is fueling it. In 2019, Juno made 2 more passes. NASA's Deep Space Network measured changes in Juno's velocity as small as 0.01 millimeters per second, caused by the gravitational pull of the storm's atmospheric column. Scientists modeled that signal and confirmed the depth. 300 kilometers minimum, 500 possible. Gravity measurements used to measure a storm's depth. Here is what the physics tells us about descending into the Great Red Spot. At the cloud tops, temperature sits at approximately -140 degrees Celsius. Outer ring winds reach 430 to 680 kilometers per hour. The crimson color comes from ammonium hydrosulfide, broken apart by ultraviolet radiation and recombined into sulfur compounds that appear reddish-orange. The storm's cloud tops rise 8 kilometers above the surrounding atmosphere, constantly exposed to extra UV that bakes the color in place. Descend 30 kilometers. Pressure climbs past 5 times sea level on Earth, temperature rising. Cloud chemistry shifts layer by layer. At 100 kilometers down, pressure equals the deepest ocean trenches on Earth. Temperature above the boiling point of water. No sunlight has ever reached this depth, but the storm's rotational structure still drives circulation here. At 300 kilometers, the confirmed base. Pressure and temperature have reached ranges with no comparison in human experience. The surrounding gas transitions towards states of matter that do not exist on Earth's surface. And the storm is still organized, still spinning, still powered by heat rising from even deeper below. Nothing built today could survive that descent. Juno measured it with microwave light and gravity from 9,000 kilometers above, because going inside was never an option. Here is the part of this story that nobody talks about enough. The Great Red Spot is shrinking, and as it shrinks, it is getting more extreme. Late 1800s, 25,500 kilometers wide. Voyager 1979, 23,000. Hubble 2017, 16,000. By 2023, below 13,000. In 150 years, nearly half the width gone. After 2012, the shrinkage rate accelerated. Observers reported chunks tearing from the outer edges, smaller vortices peeling off and dissolving. The storm appeared to be unraveling, but NASA's Hubble Space Telescope found something counterintuitive. As the storm contracts horizontally, it is growing taller. Cloud tops are rising higher, the structure becoming more circular, more compact, more intense, like a column squeezed inward and forced upwards simultaneously. Outer ring winds are accelerating. Data from 2009 to 2020 shows peripheral speeds increasing measurably. Some models suggest it stabilizes, held in place by the jet streams above and below it acting as fluid barriers. Others suggest continued contraction until it can no longer sustain itself and dissolves, possibly within our lifetimes. The storm that outlasted every nation founded in the last 3 centuries may have a finite end, and it is spending its final chapter becoming something even more extreme than what it has been. We have been watching this storm since 1665. Pioneer 10 and 11 flew past Jupiter in 1973 and 74. Voyager 1 and 2 in 1979 gave us moving images and wind measurements. Galileo in 1995 provided infrared data. Hubble gave decades of continuous monitoring. Then Juno flew 9,000 kilometers above the cloud tops and measured gravity shifts of 0.01 millimeters per second to determine how deep the roots go. 5 missions, 3.5 centuries of observation, and this storm is still revealing things that do not fit the models. 300 kilometers deep, fed by Jupiter's own internal heat, spinning for longer than any nation in modern history has existed, getting smaller, getting fiercer, still not fully understood. That is the terrifying truth inside Jupiter's Great Red Spot. Not just that it is violent, but that after 350 years of watching, it keeps surprising us. If this video changed how you see the solar system, hit the like button and subscribe. Every fact and measurement in this video is sourced from NASA official mission data and peer-reviewed science. All sources are in the description. See you in the next one.